Hey there. This is supposed to be a video on, well, with reference, a bit on the reference section, and something about sorting, and still working on my icons thing here, and the recorder, it's going to go out of sync with all this work going on, so I'll pause this here and continue in a minute, or who knows how long. Okay, sorry about that. No, I don't know if this is going to be a tutorial in the C regular section, or in the reference section. It's really not necessarily a C++ topic. However, it is in one way, one important way that I wanted to mention about. So I guess I'll put this in line, although it's on topic with Notepad or anything like that. But now the thing is, I don't know if you saw or whatever, but I added a entry in my batch file section that had to do with my quest for removing duplicates of all those icons, and this idea of comparing all files. Where did I put that? Here I have a directory I just made. Okay, now it has 11 files in it, and now these files are different and of differing sizes. Some of them have the same size, and so on. Now, you may know from math class or theory or whatever that the number of pairs of objects is given by something like 1/2 n times n, well, minus 1 really. If n is equal to 2, right, then you should get there's one pair of n equals 2, and that's what this expression would give. So, and I demonstrated a cute little proof of this. Now, I wrote a program too that returns pairs of files in a special format called getFilePairs. And you see it's printed out on each line, a file, and then a semicolon, and then another file in this directory. And each of these pairs are different. They're not the same. Now, the question is, how many pairs are there? Well, according to theory, there are 11 files, so that's 1/2. So 10 times 11, right? N times n minus 1 divided by 2. 55. So there are 55 pairs of files in here, in this list. Now the question is that how many that got printed out? That's one question anyway. One way to check that would be to pipe it into a file, but not in this directory, because it might get counted. Get file pairs. Delete me. Wow. Delete name.text. Okay, now this is an empty line, so the answer here is 55. I'm going to change something here. Let's try that. There we go. You're open and closed. One of the great things about being able to edit these files is I can go back in time and make something that failed something that's going to work. I also change something to do with that. Anyway, continuing on. Present start. Anyway, that answer is true enough. Now, if you go to what previously that directory had almost 24,000 files. The my icons directory, which is still under docs because there's a lot of things linked to it. But actually, it's not a bad place for it, for these icons. But, not documents in the sense of something you read, but it's not something that I wouldn't. Well, they aren't pictures I want to look at, right? In terms of pictures, I don't really want them in pictures. They're icons. I don't want to have a separate directory just for icons. My documents. This is analogous to my document. I think it's fair to put them here. This used to be 24,000, 20-odd thousand things, right? So that would mean that the number of pairs of things would be, let's say it was 23,000. I think it was. Times, well, let's say, and 1. And then divided by 2. And that's a pretty big number of pairs. Okay, so that's 260 something million pairs of files. So therefore, no matter how fast the search is, let's see, let's suppose each comparison takes 5 milliseconds. 5 milliseconds, that's pretty fast already, but it could be. So if we took this number and multiply by 5 milliseconds, so that's times 5 divided by 1,000, right? In terms of so this many milliseconds, right? If I want that in seconds, I would have to divide by 1,000. Now I've got a negative number because it's too big. What I have to do is get rid of 1,000 first, Okay, that gives me that many seconds. And if I divide this by 60, that gives me the number of minutes, right? And if I divide this by 60 again, I get hours. 367 hours. And if I divide by 24, that gives me days. So we're talking 2 weeks. If it's 5 milliseconds per, right? No, worse than that. That's just the total number of pairs, right? However, as you're going along and identifying things that are the same, you end up deleting them. Now, of course, I can make it more efficient maybe, but what I have is a batch file. At the end, if some things got deleted, do it again. Because I was finding that I would miss, there would be misses in a smaller directory. Try it. If it goes through and completely miss. Because suppose you're given a pair of files to check, and you got them all on a list, and then well, here's the batch file. Find dupes. Now, at first, what I was doing was I would delete the left-hand one. If they were the same, I was deleting %1, right? Because I know that as far as the iteration goes, if you look at the simple list, what's it? Find pair, get file pairs. You see the way it goes. First, you start with the A's, and then with B, C, D, blah, blah, and then you go to B, through the rest, and so on, right? Not repeating anything. But if I find a match here, I was deleting this one, and then anything from here to the end, I would ignore, because this is dead, and I can't make that comparison anymore, right? Okay, so now all of these things still might match with what was A, right? It's possible. Like this matched, but how do I know? Now the idea is that G and H should occur later on. Somewhere in the, right, it should come here. And I thought that 1 times through should be enough. If I ignore the rest, eventually these leftover ones will get compared. But it does, for some reason, maybe a bug, it wasn't. In fact, I found several bugs. But it's okay because I would just repeat it again. But of course it was way too long to do this directory or this method. Now why am I telling you this? Because I came up with an optimized method. See this get file pairs here. If I give it a /o switch, it's going to give me what I call the optimized pair of files. Originally I had this wrong. And it's subsequently fixed that. But anyway, let's get the directory listing. This here lists exhaustively the there's A here. A should be in here somewhere. Here it is. Okay. The ordering's different. Oh, here's A and B. So if I read this backwards, in fact, A, B, the first group here with B are all files of size 7 bytes. And there are 1, 2, 3. C. This is also in that group. And C and A is in that group. And D and A is in that group. So how many later on? Oh, the advantage of being able to go back in time. It was here in the video where I realized that once again I had a bug in my so-called optimized list. And I won't need to explain again that if we were to consider this group, this is from the video you were just watching, this group of files to be split up into groups of files of the same size, then we got 4 of these and 4 of these, right? 1 of these, 1 pair, 2 of these objects, and 1 of these. So now the number of pairs for 4 objects is 2 times 3 is 6, so there ought to be at least 13 results, and there are not 13 results here. Far less, in fact, and then what ensues, and what I'm going to cut out now, is exploration and attempt to fix yet the next bug in that program, and that failed. Fixed it. I thought I fixed it, and that was broken. I tried again. Anyway, I'm going to save you all that, and just cut that out and start at the point where that listing does work, and then talk about the sorting. Okay. Whoops. I'm going to fix this and restart the video. Okay, all fixed up. I got the right number. Okay, now, well, what I'm going to do now is convert this, see if I can cut out most of all this stuff, and start from a better point, and maybe I can keep some of this. Okay.